Hello students, today we are going to discuss about vector calculus. Vector calculus is a very important topic in mathematics. It has a huge application in many fields. It has application in magnetic field, electric field, heat transfer and as well as in physics. So now we are going to start with vector calculus. We all have a basic idea of vectors. So now let us see what exactly is vector calculus. Under this topic, we will be discussing velocity and acceleration, gradient, divergence, curl, solenoidal, irrotational vector fields. We will discuss some vector identities. Then we will discuss the application of vector calculus in potential functions, line integral, work done, as well as we will discuss problems on Green's theorem and Gauss divergence theorem. In today's lecture, I will be covering velocity and acceleration. Let us start the topic. Now, let us first focus on some basic concept of vector calculus. The very first term which you should understand and you should know is scalar and vector field. Okay. Now, what is the scalar and vector field? A variable quantity whose value at any point in the region of space depends upon the position of a point is called a point function. Okay, so how I can understand, there is a field. Okay, I am talking about a region and at each point I am getting a value of the function, then it is called a point function. Now when, just imagine when you are doing so, you can obtain your result in two different formats. What are those two different formats? The one format is you may get the scalar value. The second is you may get the vector value. For example, suppose if there is a metallic ball and you have heated it up. Now what you are doing, at each point you are measuring the temperature. So temperature is what type of quantity? It is a scalar quantity. So the value of the function which you are obtaining are scalars. Same we suppose on that metallic ball, I have poured some liquid. Now at each point I am checking what is the velocity of that fluid particle. So that will be the vector, because velocity means it is a vector. So what I said, when I am talking about a point function means at each point that function is taking a value. Then I said that value can obtain two types of value, either a scalar value or a vector value. That is how we separate scalar point function and vector point function. If I am getting a scalar value, it is a scalar point function. If I am getting a vector value, it is a vector point function. So let us see the definition. Let R be the region of space and at each point of which the scalar this is given. Then phi is called a scalar function. So now onwards, while doing the question, whenever I am using phi, I want to express a scalar point function. Temperature and atmospheric pressure are example of scalar point function. Now what is a vector point function? Let R be the region of space at each point of which a vector V is given. Then V is called the vector function. Gravitational force and velocity of moving fluid are examples of vector point function. Now let us see one more thing, how we will define velocity and acceleration. Now, if to each value of scalar variable t, there correspond a value of a vector r, then r is called a vector function of scalar variable t, and we represent it like this. So t is a scalar and r value which we are getting is a vector. So this is how we should represent it. Now, for example, if I talk about a particle, okay, that particle is moving on a curved path, then r can be set as expressed as a position vector for the movement, where t is the time. Okay. Now, if the scalar variable t denotes the time and r is a position vector of a moving particle, then you tell me one thing, r is a position vector. If I find out rate of change of r with respect to t, what it will give me? It will give me velocity. So if r, that is a position vector, is given, the velocity v is given by dr by dt, and its direction is along the tangent at p. Right now, We will just say velocity is dr by dt in direction along the tangent p. Later we will talk about the velocity in a particular direction also. Now, what is acceleration? Acceleration is rate of change of velocity, right? So, what will be the expression for acceleration? dv by dt, rate of change of velocity with respect to time. And we know that v is what? dr by dt. So, the formula for acceleration will be d2r by dt square. Now, let us see when I talk about in a particular direction. So velocity along any vector v is given by v dot b cap. Now what is this b cap? B cap is a unit vector. How to get the unit vector? Unit vector is obtained by vector divided by its magnitude. How to do that? We will see in the questions. Next is acceleration along any vector b. It is given by a dot b cap. Now, one more concept I should know here, that if OC represent the acceleration, it could be in any direction OC, then I can define the tangential component as well as the normal component. The tangential component is given by A dot B cap, and the normal component is given by magnitude of A bar minus tangential component into V. Okay, now to understand these formulas and these concepts, let us do some examples. Let us see the first example. Find the magnitude of the velocity and acceleration of a particle which moves along the curve x is equal to 2 sine 3t, y is equal to 2 cos 3t, z is equal to 8t at any time t is equal to greater than 0. Okay, now as I express, the position vector is represented by r is equal to xi plus yj plus zk. As per the given question, I will substitute the value of x, y and z. Now first thing I need to find out the velocity. So what is velocity? Velocity is dr by dt. So just differentiate this with respect to t. Let us see what I'll get here. It will become 6 cos 3ti minus 6 sin 3tj plus 8k. So this is the expression for velocity. Now how to get the magnitude of velocity? We all know what is the formula for magnitude. It is under root of coefficient of I square plus under square coefficient of j plus square of coefficient of k. So I will get this. So the value is 100, as I know that sine square plus cos square is equal to 1. So the magnitude of velocity is 10. Now let us see the acceleration. Acceleration is given by dv by dt. So this was the expression for v. Differentiate it again with respect to t to get the acceleration value. So I got this. Again find out the magnitude like this, and the value is 8. So this is how you have to do the question. How they will bring the variation over here? Sometimes they may say find out the velocity and acceleration at a point t is equal to 1 or t is equal to t1, any value they can give. At that time what you have to do, after getting the derivative, you should put that particular value of t. Let us see that in another example. Now look at this question. Find the tangential and normal component of its acceleration at t is equal to 1, where the position vector of a moving particle at time t is given by this. So now they have defined r. So the very first step, like in the previous question, what I will do? I will find out dr by dt. So do dr by dt. Okay. Now see, in this question they told me that I want at t is equal to 1. So substitute t is equal to 1 here. So the moment you will put t is equal to 1, what you are getting? See, when you put t is equal to 1, velocity is 2i minus 3j plus 4k. Find out the magnitude of velocity. Same way you do acceleration. Now the new thing is you have to find out tangential component of acceleration, which is a bar dot v cap. Now what is a bar? A bar is this value which we have find out in the previous step. What is v cap? I told you the unit vector is obtained by vector upon its magnitude. So what is a vector v? Vector v was this. Substitute it over here. Now what is the magnitude? Magnitude is root 29. Substitute. Now do the dot product. How we will do the dot product? 2 into 2, 4 plus 18. Okay, like this I will get the dot product. Now do the normal component. Substitute the value of A, B and B. See, you solve it and this is the value. So now in this topic, what type of question they can ask? They will define R, and they can ask you find velocity and acceleration. They can ask you find magnitude of velocity and acceleration. They can ask you velocity and acceleration in a direction of any mentioned vector. They can ask you tangential component of acceleration, and they can ask you normal vector component of acceleration. So these four things they can ask in this topic. Now in the next class, in the next video, I will be covering the basic concept of gradient, curl and divergence. Thank you very much.